Hi everyone. We are going to see about the remediation of soil by incineration and soil washing in this video. So let us see what is incineration. It is, as we all know, incineration means heating the. So what is remediation by incineration? It is a process that involves the controlled combustion of contaminated materials at high temperatures to destroy or reduce hazardous substances to non-toxic or less harmful forms. So it is mostly used for treating organic contaminants such as volatile organic compounds, polychlorinated biphenyls, pesticides, and certain types of hazardous waste. So mostly this is for hazardous waste, right? And here, let us see does this work. So we have for all methods. First method is to characterize the contaminants. What type of contaminant is present? Next, we have to prepare. Go for the preparation of contaminated materials, and then third one is incinerate. We have to choose which temperature to be operated and where to be processed. So the incineration process, and next one is the combustion and thermal destruction, and fifth one is pollution control and emission monitoring, and next one is residue management. So here the method is we have to carefully do this process because the combustion of the toxic materials like as we all saw, volatile organic compounds, polychlorinated biphenyls, pesticides, on these all are potential air pollutants. So we should be very cautious that the pollutant should not be emitted into the atmosphere, resulting in long-term air pollution. So pollution control and emission monitoring is a very important concept in this incineration. And finally, after the burning we have some residue. So what to do with that is a very important process in what is method of concern, or it's a thing to be in concern for this incineration process. And what are the advantages of incineration? It is quite visible that we are going to destroy a wide range of organic contaminants, including persistent toxic substances. Everything is burnt off. And highly efficient method in reducing contaminant concentration and achieving cleanup goals. Volume reduction and contaminate materials, minimizing disposal costs and space requirements, and versatility for treating different types of contaminant materials, including solid, liquid, and sludges. So mostly it is suitable for all, except the thing is it causes pollution. And what is the limitation? That is energy and resource requirements. We have to, for burning we want a high amount of energy set also, that it is a significant task, and it may produce greenhouse gas emissions and other environmental impacts, plus air pollution and potential for air emissions. As I told you, it is may cause air pollution such as dioxins, furans, volatile organic compounds, which require effective pollution control measures. And regulatory, should go with the regulatory compliance. There are strict rules against this air pollution, so we have to follow that. And cost also, it's an expensive method. We have to go for a incinerator, erection of incinerator, and large scale projects or complex contaminants are present. So it is very important thing to be. And next one is soil washing. So this method is particularly effective for soil contaminated, soluble or loosely bound contaminants such as heavy metals, pesticides, petroleum, hydrocarbons, organic pollutants, etc. So in this process, the major steps are excavation and preparation. Is excavated from a site, transported to it is a exitive method. So we have to take it to another place, and where the soil washing facility or a treatment area, the soil may be screened or sorted to remove large debris and aggregate. So we have to screen. So large debris can be removed, and only the particular type of soil can be chosen. And next one is washing and leaching. The excavated soil is placed in a washing or leaching system, which is mixed with water and washing solutions to dissolve or immobilize contaminants. The soil water mixture is agitated or circulated to ensure thorough contact between soil particles and the washing solution. And next one is separation and recovery. So after this washing, the soil water mixture is separated into a soil solid and into soil solids and contaminated wash water. Various separation techniques are available For this, such as sedimentation, filtration, centrifugation are used for separating soil particles from wastewater. So water and solid particles are removed by this process. And now we have to go for the treatment, because most of the soluble components come into water. So that water should be treated. So soil, the contaminated wash water is treated to remove or neutralize contaminants before discharging or recycling. So then it is the dewatering and soil handling. The washed soil solids are dewatered to remove excess moisture and prepared for reuse, disposal, or further treatment. Dewatering techniques such as drying, mechanical pressing, evaporation may be employed to reduce the soil mass. So we are just taking the soil from a particular place, then we are going to a facility where it is taken for soil washing. Before that, we have to separate the segregate the waste. Larger debris are removed. Then we have to wash with water and add washing solutions. Then the wash water and solid components are removed, and wash water has to be separately decontaminated, and the soil also has to be decontaminated, and it has to be dried and it has to be disposed. This is about soil washing. So it's effective removal of soluble and loosely bound contaminants, versatile for treating a wide range of contaminants to soil types and site conditions, and reduction of contaminant concentration and risk to human health is less, and also minimization of soil volume requiring disposal and associated cost is possible. And limitations: ineffectiveness for treating contaminants highly bound, so tightly bound particles, contaminants cannot be removed by this method. And generation of contaminated wash water and residues require proper treatment, and so the wash water has to be properly treated.